Anna Povzner is an engineer who's a return guest to the show, and she and her colleague Anastasia Vela both have been working on multi-tenancy in Kafka as a part of Confluent Cloud. It's part of our ongoing series on things we do to Kafka to make Confluent Cloud work. Anastasia also started as an intern here at Confluent and worked on some pretty important work that made it to production. So she talks a little bit about that experience too, which is super cool. Streaming Audio is brought to you, as always, by Confluent Developer. That's developer.confluent.io, the website that's got pretty much everything you need, in my opinion, to get started learning Kafka and Confluent. If you do any of the labs or the examples that use Confluent Cloud, you'll want to sign up for Confluent Cloud, obviously, and you want to use the discount code podcast100 to get an extra $100 of free usage credit. Now let's get to Anna and Anastasia. Hello and welcome to another episode of Streaming Audio. I'm your host, Tim Berglund, and I'm joined in the studio today by Anastasia Vela and Anna Povzner. Anastasia and Anna, welcome to the show.
Thank you. Thank you for having me.
Now, you two are both engineers, and Anastasia, you have the kind of cool experience of having been an intern here and now being a full-time engineer. And Anna, you're a several-time repeat guest on the show, but just in case this is somebody's first episode and they somehow don't know who you are, I would love for both of you to just tell us a little bit about yourself. And Anastasia, if you want to even go into a little detail on your project and the experience of being an intern and converting to full-time and everything, you go first.
For sure, yeah. So my name's Anastasia. I am a software engineer on the cloud-native Kafka team. Kafka Cloud Fundamentals is the subteam. And I started working with multi-tenant systems when I first interned back in summer of 2019. And this was when I contributed to a really critical multi-tenant feature that is auto-tuning tenant quotas, which would help provide additional broker protection. So since then, I've completed my degree and I returned as a full-time employee in August 2020, and I'm continuing working on creating awesome features to make Kafka cloud native.
I love it. And Anna, returning guest. In fact, the most recent episode that I think we did was about multi-tenancy. But tell us about yourself, just in case anybody's new to the show.
Yes, thank you for inviting me again. So yeah, I'm Anna. I've been in Confluent now, actually 6 years and slightly more. And I worked on I work on multi-tenancy about 3 years now in Confluent. It's something that actually I have about 10 years of experience in multi-tenancy before. I did my PhD around the topic. At that time, it was not system like Kafka. It was mostly on a disk performance, on a storage performance. But it's something that I've worked for a long time. And then in Confluent, when we go into cloud, and multi-tenancy is one of our kind of fundamental features in cloud, I started working multi-tenancy. And we already spoke, I think last time we mostly talked about multi-tenancy in Apache Kafka, little bit.
Yes, yes.
Right, and this time, right, so we work, this is multi-tenancy mostly in cloud. I, worked on it, I was a tech lead on it, and then because that kind of multi-tenancy becomes very important, and we have few multi-tenant tiers that we kind of have available in Confluent Cloud. Now we have the whole team that is owning the multi-tenancy, which is under Cloud Native Kafka, which we call Kafka Cloud Fundamentals. And the reason it's fundamentals because it's basically fundamental to our offering. So I think that's about me. And basically, I think this time I was hoping to talk more about actually cloud part and a little bit, of course, to compare it with Kafka multi-tenancy.
To start with, though, tell us about Kafka multi-tenancy. Out of the box, what is there? The difference between what you need for a cloud service and what AK has is big. But what's there to start with?
Yeah. So in Apache Kafka, so there are actually it does have multi-tenant capabilities, but the use case, I would say, is kind of different. On Apache Kafka, the reason it was built was mostly around in the context of an on-prem data center. And so, imagine, I would say, very common use case would be, you have a company. In your company, you have one Kafka cluster, which serves all the workloads. And so the idea you can share the data across the company, and so that different teams can collaborate. But obviously, because those are different teams, in a sense, those are different tenants, right? You can have different applications, some of them more critical, some of them less. And so to be able to actually host that, right, even though you might share the data or you might share the cluster, you need to be able to isolate data in some cases, right? Because some data could be more sensitive. So you need to be able to control who can access cluster. I mean, you don't want for example, randomly somebody just start running application. They are maybe not very well configured. They just take over. Lots of bad things can happen. So you need control on isolating data, on isolating your performance. You can actually also isolate user space so that you don't have conflicts on topic names. So that's what Kafka provides. And you basically would need to set up your cluster and configure, for example, quotas. This is the way we control performance. So you just configure and making sure that any of application does not use more resources than. And so that's kind of how you do it. You kind of set it up, and then you know what your workloads, you configure your quota, you configure your isolation, and basically, here it is. You run Apache Kafka cluster.
And yeah, those are all Apache Kafka. That's the unmodified, not Confluent Cloud. So to get to cloud, and I guess you've kind of been talking through some of this, but just kind of name off for us what are the things that have to change to make because I know those Kafka multi-tenancy things you listed off, they're there, but they're not everything you'd want. And if we've got now shared clusters in like a basic or standard cluster in Confluent Cloud, there's a tremendous amount of sharing going on. So what other things have to happen? And by the way, all these questions can either be either one of you. It just you guys tell me.
Yeah. Let me start because that kind of would lead to, I guess, Anastasia, more detail on the project. But actually, I think the most interesting the first thing is actually use case is different. If we think about it, right? It's not that, here you sharing, you kind of really thinking of sharing your application, and it's in a company, you know them, you know your workloads most often.
Right.
You can go and ask someone.
And ACLs could be the most, this team's not allowed to read this data or something like that. That's
exactly. So it's you kind of still have this, but you also can also go to someone and ask how much you expect how much data you expect also for performance.
Your friends, maybe there's boundaries, because boundaries are healthy, but you're still friends.
You still exactly.
Yeah.
But in cloud, it's also obviously in on-prem, you kind of the whole idea, okay, you have this one cluster, it's very easy to manage, right? It's obviously in cloud the same thing, but the main thing that why you want multi-tenancy there is for cost efficiency. Right? Because imagine when you're hosting a service, it could be anything like Kafka, could be database, right? Often, when you buy service, you might have it's very common to have pretty small workloads, right? You can maybe run few megabytes per second, but you still, as a cloud, as a service, you do expect availability. And so in that case, you still would be we would advise you or we as a service, right? We will still configure 3 replicas, meaning that you might have it's a 3 broker cluster at least. And so you basically you kind of still have certain size of that cluster for availability, which is not doing much, very much utilized. And so then in that case, you actually pay, the whole point, why you have multi-tenancy is that you kind of can do opposite, right? You take all this, all the small workloads, can just go in one big cluster and you utilize very well, and you have cost-efficient service. Obviously, it's cost-efficient to host, and then you can, you share that cost efficiency by providing more cheaper service to customers.
Right.
And so, yeah. But what you think about, I think the main thing about this, right? So basically, now you think of cost efficiency. When you come back to that on-prem, design of, multi-tenant kind of setup, right? Especially to set all these quotas, right? You you actually need to think about capacity. It's kind of manual. Like obviously when you have like just normal like one workload, you size the cluster. When you have multiple tenants, you still need to size your cluster. Yes. You need to think, okay, I have some critical workloads. I want to make sure they have capacity. You reserve that. Reserving means like you make sure that there's capacity. Then you maybe reserve for maybe less important workloads and some capacity, but then set all these quotas limits on how much resources you can use. And so all that you basically, if you see, you need to make those decisions. How much capacity, and usually you kind of can guess, like you can either over allocate that capacity, or ask the other team how much do you really need and set it. But it's, as you can see in cloud, is very different. Like you're not running like our customers or the customers of the hosted service. They don't tell us what it is. They actually opposite. They just want us to give credit card. I just want to get my bandwidth and I don't want to worry about anything else.
Then we don't like my bandwidth, or not use it all, or use it all, or you want to be free to just have your workload run. And the whole idea is you're paying somebody else to care about that. So the customer doesn't want to think about it.
Exactly. And they don't want us to go on them to ask, oh, can you please tell us how much workload? And it's actually it's not scalable at all. No. So basically, as you see, like it's actually very hard, like, take the Apache Kafka and then like, okay, let's put it in the cloud. So in that case, but we still did it in a way that we started, right? We wanted kind of deliver that feature, which is pretty complex. So we had to start with mechanism that Kafka has. But those mechanisms means that what we did actually very, very early on, and that was maybe first month when cloud was available, if anybody remembers, we ended up kind of addressing this by setting very small limit that customer can get on bandwidth, which is 5 megabytes per second. And we're like, okay. And then we had still very few customers. So you kind of reserve enough headroom and kind of see statistically how many of them can spike at the same time to the full capacity. And then, so there are a few of those things, but obviously it's kind of very fragile in terms of like, you do want, if you get in more customers, those assumptions does not hold, or you need to, again, reserve more, which is go against your capacity or your cost efficiency. Or you potentially actually, right, if you over that capacity, you can actually have unhealthy cluster and availability loss, which is what we also don't want to provide. And then that's what led us to actually one of the first problems we thought, which is interestingly was pretty early, was like, okay, how do we know that we can use capabilities of cloud that you can always get your, more computing power, more storage when you need it. But it's still obviously it's about data, right? Even if you expand your cluster, you need to move data. It's still a time, right? It's not instantaneous, because any data movement, it's a physical resource. Yep. And so obviously it's a time. So you need to kind of have solve the first thing you want to solve is what do you do in those temporary times when there's not enough capacity, but everybody wants to use more? And
okay, because you would have, that's an outage.
Exactly. And this is, yes, for the customer, or it could be maybe very degraded performance, which is also could be an outage, because you don't know how application can
one man's degradation, one person's degradation is another person's outage, right? So
exactly. And so that's how we come the first, which is very interestingly, that was a project that when Anastasia joined, we gave her a problem, which was what do we do? There's pretty much a problem. You have not enough capacity. How do you address it?
So back in the halcyon days of 2019, Anastasia, yes. What was that problem statement? If you remember.
So it was just we oversubscribe our brokers because we want to be as cost efficient as possible. But there's a problem because we don't have enough capacity for our tenants to use when they do want to use up to the max. So an obvious solution to this is just to decrease everyone's quotas and what they can use, so that it's equal among all tenants. And what we call this a fair limit. But determining what this fair limit is really difficult to do, actually. Because how do we define fair? It's super subjective. Mm-hmm. So in an ideal world, I guess fair would be a tenant can use however much they want to, right? But we can't do that, obviously.
Because the whole thing is you're bumping your head.
Yeah. So an alternative was also to reduce everyone's quotas proportionally to like their original quota. So this means that a tenant who was originally allowed to use more than another tenant can end up getting more allotted to them in the end, so that they both don't see the same quota in the end. And yeah.
Gotcha. That did that go to production? I mean, tell us about the building out of the thing and how the summer went, and you're an intern back then.
Yeah.
It seems like a big problem for an intern.
Yeah. So there was no solution defined, which was what I really liked about the problem. I was just given a problem and I had to determine like what solution we could do. And so in the end, we did end up going to production. And initially we had targeted the problem towards request quota because we see more overload on CPU utilization rather than like on bandwidth. So we focused it more on making sure that CPU wouldn't get overutilized.
Okay, and request quota is a good proxy for CPU load.
Yes, yeah, definitely.
Okay. I guess that makes sense.
So afterwards, I returned and continued more on this, or I made another improvement, basically.
Oh, nice. This is after you completed your senior year and
yes,
back.
Yeah. This is after my senior year. I came back as a full-time employee, and I had another improvement. So improvement was to also auto-tune on bandwidth. So as I said earlier, it was only on request quota. So what we decided to do was also auto-tune on bandwidth, which was much more rare, but it still does happen. And rather than manually decreasing the process or manually decreasing the quotas, we would auto-tune the quotas such that according to this algorithm that I described.
Nice. Okay. What was next after that? Like, is that all there is to multi-tenancy and cloud? You've got, and I want to back up a step and I like to restate things to make sure I've got them in my head.
Yeah, for sure.
This is for there are three cluster types in Confluent Cloud. There's basic, standard, and dedicated. Dedicated, I think, multi-tenancy is not a thing. Like, there's dedicated instances, and that's the whole theory of them being dedicated. Basic and standard, they're cheaper to operate because the unit costs are lower because they're multi-tenant. So that's the big multi-tenancy problem. And you've got your topics are sharing a Kafka cluster with other people's topics, and your view in Confluent Cloud and the UI of there being clusters is an abstraction that we're putting on top of things. And so you have to make sure that you're trying to make sure that everybody does the best job meeting the performance contract when you're bumping your head up against a load, when the statistics of things just get a little upside down, and there you go. Is that all there is to it? So what else is there to cloud native multi-tenancy? And Anastasia, if I'm glossing over something in the original problem, just correct me. But
yeah. So there's actually another project which is similar to auto-tuning that we were working on. So auto-tuning was strictly for a broker-wide. But what we want to do now is to make sure cluster-wide resources aren't overutilized. So,
like what?
So we have cluster limits to make sure that clusters don't, or so that tenants don't use more than what's available in the cluster. So.
Yeah, maybe I can little bit, I just maybe like kind of step back for a second, because I think what we kind of didn't mention, but it's all in blog post, there is much more, is that maybe it's actually good. Let me just come back for a second to the cloud native part, because I think there is one piece we didn't mention, which would actually be helpful then to come back to Anastasia, that current project, right? So we describe like basically only so far we kind of touch on this one problem that, when, you need more capacity, and once you're expanding and getting more capacity, you're fairly making sure that if you somehow have a little bit of degradation, all the tenants kind of fairly, get very small part of it. You kind of amortize the degradation, and with that whole auto tuning thing that you kind of temporarily reduce quotas. But because of so many tenants, right, it's kind of small impact on each until you expand. And that's why that specific project that Anastasia did was pretty critical, because we actually use the same mechanism for, bandwidth, like protecting from bandwidth overload, from CPU overload, and then later for connections, because we kind of need to also keep connections. So that's kind of one thing, but there is much more, and I would refer to the blog post. But one of the important things about cloud native, which I want to bring up, is that, right, we kind of mentioned like three things already, but not directly, right? One is like, yes, you have this expectation on, that you can instantaneously get your resources, or near instantaneously, and you only pay for what you're using. So all the space you go model. So that's what we need, like kind of this idea that, as soon as we need more, we give more. Then you have, obviously, as I mentioned, right, because I was talking about availability, expectation on good performance. Those are your SLA, SLO, right? When you buy service, you expect certain, quality of service. Mm-hmm. And then, of course, you cost efficiency, like the whole point of multi-tenancy. Otherwise, why we do it? But the final thing is that abstraction, right? When you give when somebody buys a service, like in Apache Kafka, the way you set all the quotas and manage it, you actually set it all per broker. So you know your cluster size, you decide per each broker how much quota, then you add it up. When you expand or shrink it, you start recalculating. It's very not easy to. It's kind of like it depends. Like you already know how to do, you will do it. But right. On cloud, it's not something that you want to expose. And especially this is a cluster you can potentially share with some other people. You don't really care, and you really want to see that it's as experience, you want to have it on your own. You don't really want any experience that, I know about all those details. So you don't want to, we don't want to have any brokers exposed or any of those details, because it becomes just operationally probably as hard to manage as on-prem.
That's the whole abstraction of Confluent Cloud. Is supposed to be serverless Kafka. You're not supposed to
exactly. And so when you buy something, you really, in reality, when you buy, you think in your application terms. You think, okay, what I care is Kafka. It's Kafka application is I get a bandwidth and I get a latency and I get some storage, some number of partitions, availability, just kind of application side. Mm-hmm. But in a cloud, why that abstraction is actually not that trivial, because we give you bandwidth. We also, in the back, we have to think about CPU, because you need to have enough capacity. So we kind of manage it all for you in the back, how much resources you're using and so forth. So this is all in a blog post. And the final big piece is that, because we had to expose, we don't want to expose brokers, right? So the way we exposed bandwidth limits, because we do, when you buy Confluent Cloud, you know what kind of limit you get on those non-dedicated clusters. Right now you get 100 megabytes per second, separately for produce and then for consume. And those are cluster-wide. That's why we had to we kind of build that layer, another layer, but it's in the broker. It's actually embedded in the broker. So it's Kafka cluster have this knowledge that we set quotas per cluster, and then brokers decide how to slice it to them, how much quota they actually enforce. So that
the brokers have multi-tenancy metadata.
Exactly.
Gotcha.
And so all that, we have the pipeline, how to get this metadata, algorithms, how to, allocate those quotas. And originally, initially, again, we started always something very simple, especially when we have small clusters, less tenants. We just, very, very simple, kind of distribution of quota, which kind of leads to what I think, now I'm coming back when Anastasia was describing with a new project, because it's basically, finally we're doing something more smart. in basic, once we scaled, now we need to be more careful how we kind of divide that quota between brokers. So I'll give it back.
Yeah. So we're trying to be more smart in how we allocate bandwidth across for the cluster-wide limit. So currently it's just 100 megabytes per second for multi-tenant clusters, and it's just evenly distributed across all brokers. But becomes an issue as we increase the number of tenants for this multi-tenant cluster, because it is equally distributed.
Got it. So for very large,
Yes.
for whatever that means in the way that Confluent Cloud allocates tenants to clusters,
Yeah.
and it's some number n.
Yeah.
When that gets up there, that gets more difficult. Okay.
Yeah. So it works well with small or medium clusters, obviously, but definitely not larger ones.
Got it. And you're trying to make it be smarter. Well, I think I can say you'll find in your career as an engineer, it is a process of building something that's not smart because it's the best we can do, and then making it a tiny bit smarter. And that's just kind of how software works.
Yeah.
Awesome. So, you two, thank you for this. What briefly, we're up against time, but what, and Anastasia, you were kind of mapping out the future, but what's the other kind of thing you're pushing into in multi-tenancy? Where do you see the future going? And Anna, that can be you if you'd like.
Yeah, so we definitely want to build, we kind of right now with like this project, we're focusing a lot to make sure that we still deliver, we deliver everything we promised with a bigger scale of basically clusters and tenants, right? So basically lots of we were able to do pretty simple approaches, quickly, make this happen, cluster-wide bandwidth, isolation with kind of a smaller, size, a smaller number of tenants. But once we scale, those basically approaches become a little bit too simple and they not maybe work as well, because at scale, for example, in that case, why it's important to distribute this quota better with higher scale, because you want to be able to actually provide the capacity we promise, or provide the bandwidth we promise. So it's really we're focusing a lot on kind of keeping up our promises while we are scaling and getting more customers, so it still works. And it also includes providing more visibility and kind of more monitoring to that, and how we operationalize, because so far sometimes when we example that Anastasia was describing with auto-tune bandwidth, right? Even though it was rare cases, right, we didn't implement it, but if we have monitors, if somehow there is some overload, we get notification, and then on-call will go and mitigate it. So all that we're trying to basically make sure that we reduce on-call time, so we operationalize it. How do we actually, one hard question, for example, right? If you have, because you have so many tenants, we have thousands of tenants, but on a cluster. So if any of the tenants have performance issues, how do you actually detect, how do you go and observe what's happening and how you resolve it? That's very hard problem to solve, because it's so many. And how do you know, right? Because there's so much else happening. So kind of resolving that. And then we are basically looking a lot, even with scaling, right? We need to make sure we still, as we scale and having so many tenants, it's become more important. We need to be more explicit how we manage availability, right? So if anything happens, because it could be bugs, right? You want to reduce the blast radius, make sure that nothing, we still maintain our I think we have 49 for standard. So it's pretty high availability. Yeah. So once you scale, that becomes, you need to actually have much better, software to handle those kind of, provide this availability. So that's pretty much what we're solving. So it's lots of hard problems
yes.
to solve for us.
My guests today have been Anna Povzner and Anastasia Vela. Anna and Anastasia, thanks for being a part of Streaming Audio.
Thanks for having us.
Thank you, team. It was really fun. Hopefully we do more so we can have another podcast. Thank you very much.
Yeah, thank you.
And there you have it. Thanks for listening to this episode. Now, some important details before you go. Streaming Audio is brought to you by Confluent Developer. That's developer.confluent.io, a website dedicated to helping you learn Kafka, Confluent, and everything in the broader event streaming ecosystem. We've got free video courses, a library of event-driven architecture design patterns, executable tutorials covering KSQLDB, Kafka streams, and core Kafka APIs. There's even an index of episodes of this podcast. So if you take a course on Confluent Developer, you'll have the chance to use Confluent Cloud. When you sign up, use the code PODCAST100 to get an extra $100 of free Confluent Cloud usage. Anyway, as always, I hope this podcast was helpful to you. If you want to discuss it or ask a question, you can always reach out to me at tlberglund on Twitter. That's TLBERGLUND. Or you can leave a comment on the YouTube video if you're watching and not just listening, or reach out in our community Slack or forum. Both are linked in the show notes. And while you're at it, please subscribe to our YouTube channel and to this podcast wherever fine podcasts are sold. And if you subscribe through Apple Podcasts, be sure to leave us a review there. That helps other people discover us, which we think is a good thing. So, thanks for your support, and we'll see you next time.